Hey, good morning, everybody. This is Mr. Ainsworth, and we are in MRWC here, and we are going to talk about how to analyze different methods with radicals for activity 3v3. So it's just another little prep here to help you guys out, especially in this online era where it's a little bit more difficult than usual because I am not with you. So this is just another little helpful video to help you get the right mindset that when you go into this activity, because this is probably your first challenge and activity in respect to numericals and dealing with numbers like radicals and what are called irrational numbers like root 2 and root 3 and all of those radicals that cannot be simplified. They're irrational, and so this section 3 is all about irrational numbers. Well, this and this is just the tip of the iceberg, but we're going to get right into it. So I'm going to analyze these things two different ways, or I'm going to simplify these two different ways, which is what you're going to be doing in the activity. You're going to be taking a look at two identical expressions simplified totally differently and analyze the methods from within it, because later on you're going to have to do that all by yourself. Okay, so one common technique that is typically done with radicals, and it's because you guys were taught ever since you were little, is to distribute. All right, so distribute first. I'm talking about here just flat out distribute and multiply. Okay, so distribute first. Okay, so that's the first basic thing that people do. It comes natural because you guys were trained to distribute. So this is going to be equal to, let's see, 2 root 3 times root 6 is 2 root 18, because 3 times 6 is 18. So you get 2 rad 18 plus, because there's a plus there. 2 times 4 is 8. You multiply the non-roots first. Root 3 times root 15 is the square root of 45, because 3 times 15 is 45. All right, so you multiply the non-roots, 2 and 4 first. Then you multiply the roots together. You basically multiply it like terms. It kind of makes sense. Okay, and then you got to simplify these. So step 1 was to distribute. Step 2, simplify roots, like you were trained to do. We've already talked about this before, so this should be easy. The factors of 18 are, 18 are 2 times 9 and 3 times 6, and of course 1 times 18, but that doesn't help us out any. All right, so I'm going to use 2 and 9 because they're 9 is a square. So this is your helpful number here. All right, so 2 times root 9 times root 2. I'll simplify that in a minute. And then 45 is simply 9 times 5. Also 3 times 14, but 3 times 15, but neither one is a square, so you're going to have to use 9 and 5. Notice I put the root 9 first because you can simplify it. So you get 2 times 3, because root 9 is 3, times rad 2, plus 8 times 3, because root 9 is 3, times rad 5. And you simply simplify. Obviously you get 6 rad 2 here, and plus 24 rad 5 here. And these are unlike, so you are done at this point unless you want to factor out the common factor. So if you look here, the 6 and the 24, they have a common factor, right? So if you want to factor out the 6, you can. So you can factor out the 6 if you like, and you get 6 times the quantity root 2 plus 4 root 5, because 4 times 6 is 24. You factor out the GCF right here. So the last thing I did, step 3, you simplify the roots. I did that. The square root of 9 is obviously 3. The square root of 9 is 3 here. You multiply 2 and 3 to get 6. That's not too hard. And then I factored out the GCF. So the last major step I did, is factor out GCF. Not that you have to do that. I just did it. You'll see why here in a minute. And you're going to have to recognize things like that. Okay, so get used to it. The analysis is critical in the MRWC program. You have to be willing to look at your colleagues or your classmates' work and critique it and analyze it. So being able to do something like this is important. The other way to do it is totally different. You can factor the roots first. Okay, so notice that I didn't say distribute first. I said factor the roots first. So step 1 over here, a totally different way to handle this, which is kind of cool. You're going to see this, is to factor first. Okay, so I'm going to leave 2 rad 3 as it is. I'm not going to distribute. Okay, no distributing. The factors of 6 are 2 and 3, or 3 and 2. The order doesn't matter there. The factors of 15 are 3 and 5. So basically I factored the number inside the root called the radicand. And notice there's a common factor. And the reason why I mention this is because, you know, when you get experienced, you see those things. The factors, or the common factor of 6 and 15 is 3. And so what you can do is factor it out. You can factor this and this. So factor out the GCF, kind of how I did the last step over here. So let's do that. So if I factor that out, I get 2 rad 3 here in the beginning, right? I factor out the root 3, so times root 3. I'm going to highlight that because that's the term I factored out. And then what I have remaining? Well, it's very simple. I have root 2 plus the 4 root 5. So root 2 plus 4 times root 5. Now if you don't believe me, just distribute the root 3 back through and you'll see you get the same thing. So distribute and work backwards to check your work. And now, obviously simplify, so I get 2 times 3. Root 3 times root 3 is root 9, which is 3, times root 2 plus 4 rad 5. And obviously 2 times 3 is 6. And I get 6 times rad 2 plus 4 rad 5. Okay, and notice they're the same. So there's 2 different ways to do things. And as you get experienced with radicals, which is what this activity is gearing you up for here, it's having you analyze different ways of doing things and realizing that there's different ways of doing things. Because most people think that method 1 is the only method. Distribute, 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 because you were trained since a little kid to distribute. Well, guess what? You don't have to distribute. You could factor first, then factor out the GCF with no distribution at all. Okay, so step 1 was factor the roots first. Step 2, factor out the GCF. Step 3, which is right here. Actually, let me put it in a different spot. Step 3, simplify. Okay, obviously root 3 times root 3 is 3, so I simplified right there. And then I simplified 2 times 3 to be 6. So, you know, hey. So there's a way to do this without even simplifying at all. And that's what you guys need to realize, is that there are different ways of doing things. All right, and you need to be flexible. That's what I mean up here in the very beginning. You got to be flexible. Flexible with the mathematics, okay? And later on, you're going to have to see structure, okay? To you right now. Okay, so let's get into it a little bit more. So let's suppose we have this one here. So notice that expressions are the same, but let's tackle them totally differently. Okay, so the key on this one here is look for structure. So the key, okay, is look for structure. And I talked about that in my previous intro video heavily, okay? And I see that this the terms are the same here, root 7 and root 2, root 7 and root 2. So the terms are the same. A and B are the same, and one's a minus and one's a plus. All right, one's a difference and one's a sum. Okay, and whenever you have a difference times a sum like this, it's always equal to a squared minus b squared, which is called a difference of squares. Okay, so that is one way to handle it. So a difference of squares. So that's method 1. That's the first thing I saw. So what I'm going to do is square both and subtract. So this is equal to root 7 squared minus root 2 squared, and that's it. Okay, and the square of root 7 is 7, the square of root 2 is 2, and you get 5 and you're done. So you square both and subtract. That's what I was talking about in the previous video. So square both and subtract. That's where the name difference comes from. But that's, you know, the difference of squares in simple terms. So that's method 1. Method 2, flat out distribute. Okay? Distribute both terms. Distribute. Okay, so here we go. I'm going to do it. So root 7 times root 7. That's the square root of 49. The square root of 7 times the square root of 2, which is the square root of 14. Minus root 2 times root 7, which is minus root 14. and then minus root 2 times root 2, which is minus the square root of 4. And notice these right here, okay, these add to 0 because anything minus itself is 0. And so what do you get? Well, you get this square root of 49, which is 7, minus root 4, which is 2, and then obviously you get 5. So notice that these are the same, but one, I use distributor property, or if you guys were thinking FOIL, that's the same thing, okay? FOIL is just an acronym for the distributor property, first, outer, inner, last. I mean, it's distributing, guys. And so distributing and simplifying, and then right here, I saw the structure, okay? I saw structure, which is called the difference of squares, and all you do is square both. And when you do that, you don't even need to write this out. Squaring root 7, you do that in your head, you get 7. So technically, this part right here, all right, this is a mental step for experienced people. I mean, you do this mentally. I mean, that should be easy for you guys. And then subtracting 2 from 7, oh, that's obviously mental too. So this one here, if you see the structure, you can go from here to here without even doing anything. I see just 7 minus 2 in my head and I get 5. I don't need to multiply 4 times. So this one's more efficient for me. Okay, by that I mean less steps. Okay, because I could skip this middle step here. In fact, I can skip both steps and get right to the answer. And it also means it's faster for me. It also means it's easier for me. Now, that may not be the case if for you. So if distributing is easier for you and you can't see the structure yet because you're not experienced enough yet, then continue using method 2. But you're just going to take a lot longer than everybody else. This will take more time than anybody else. And I know that because I've been teaching for 29 years. And I know that students that know method 1 are done in like 5 seconds. People that are doing method 2, 30 seconds or so. You know, it's just there's a big difference. So when you know the structure on things, mathematics, and you can see the patterns in the structure, you tend to be faster than everybody else. Not that speed is more important than anything, it's not, but it kind of helps sometimes. Okay, number 3. This is the most challenging one. Okay, so how would you handle this? We're multiplying trinomials. Now, if you were back here, let's say, if you're, let's say, the method 2 person here where you're distributing all the time, okay, well then that's what you would do here. So the method 1 is distribute 9 times, okay, because you got to distribute each term 3 times. There's 3 terms that you have to distribute 3 times each. 3 times 3 is 9. So this method here, distributing, which is very commonly used, all right, is going to take a while. So distribute 9 times. Here we go. We're going to do it the long way first. Okay, now distributing, I'm going to use colors here. So I'm going to distribute through the root 5. Okay, so here we go. Root 5 times root 5 is obviously root 25, which is 5. Root 5 times root 3 is root 15. And root 5 times root 2, minus root 2, excuse me, is a minus root 10. Okay, so I just distributed the first term 3 times. Now I distribute the root 3, excuse me. So I go root 3 times root 5, which is root 15. Now I'm on second row here. I'm going to put a plus sign because it's positive. Root 3 times root 3 is root 9. Root 3 times root 2 is root 6. And now the last one you have distributed is root 2. So you take root 2 times root 5, which is root 10. So it's positive. And then root 2 times root 3 is root 6. And then root 2 minus root 2, or times negative root 2, is a negative root 4. And then you got to combine these. Okay, so here we go. So I got 5 here. I got 2 rad 15 here. I see 2 roots. 1 root 15 plus 1 root 15. 1 root 15 plus 1 root 15 is typically 2 root 15 because 1 plus 1 is 2. You add the coefficients. All right. The negative root 10 plus the root 10 cancels. You get the 3 here, so I'm going to put a 3. Right, root 9 is 3. This will give you a 2 rad 6 because there's 2 of them, and then a minus 2 because root 4 is 2. Now you have to simplify. So 5, 3, and a minus 2. 5 and 3 is 8, minus 2 is 6. All right, so I get 6 here, plus 2 rad 15, plus 2 rad 6. There we go. And these are unlike roots, so unlike, you're done. Okay, cannot simplify any further. Okay, so at this point, is there a different way of doing things? And the answer is yes. If you see structure, so using structure. So let's talk about that. I see that this quantity and this quantity are the same. So I'm going to consider them like one term. And then I see a plus here, and I see a minus here. So this is like a plus b, and this is like a, oops, that's supposed to be minus sign, a minus b. So all I do, okay, I see the structure. This is a difference of squares. Difference of squares. Okay, this is a squared. This is equal to a squared minus b squared, which means I got to take whatever a is squared minus whatever b is squared. So here we go. So a is this root 5 plus 3. So I got to give it a hug, all right, because it's a binomial, and I got to square it. Minus, that's the first term now. See, there we go. Minus the second term. Now the second term is root 2. That goes here. So I got to take root 2 and square it. Okay, so now the second structure. The second structure is how to square binomial, and I talked about that in our previous lesson. You got to square, multiply, double square. So you square the root 5 to get 5. You multiply the 2, you get root 15, and then you double it, so you get 2 rad 15. And then you square the last to get 3. So this gives you all of this right here comes from this binomial squared. You have to go back in your notes and get practice. Square, multiply, double, square. And then you just have to square the root 2, and obviously that's a 2. And then you simplify. And notice that these, where's the, shoot man, what happened here? I messed up somehow. What happened? So root 5 to root 15, root minus root 10. Let me just, I'm double checking, I made a mistake somewhere. Oh, in the second term in blue here, root 3 times a negative root 2. Okay, I'm going to highlight my mistake. It's right here. That is a minus sign. Root 3 times negative root 2 is negative root 6. So I'm going to fix this. I'm going to put it right there. Negative root 6 plus root 6. This term should not be there. And so you get 8 minus 2 is 6, plus 2 rad 15. That's all you get. So this cancels. Okay? I made a little mistake. I saw that because I did it a different way, and I got a different result. 8 plus 3 is 8. Excuse me. 5 plus 3 is 8, minus 2 is 6, so I get 6 plus 2 root 15, and now these are the same. Okay, now by the way, that is a really good thing that kind of happened right there. So notice that I did it differently, and I got a different result, which should not happen, okay? And that told me that obviously I made a mistake, because I didn't see a mistake in the second method, so I went back to the first method, and I made a sign error. When I distributed the root 3 to the negative root 2, I should have got negative root 6. That's why I fixed the mistake there. And negative root 6 plus root 6 cancels out to 0, so I shouldn't have a root 6 as part of my answer. And because I didn't get it in method 2, I just got 6 plus 2 rad 15, which is now, after I fixed it, that's what I got over here. All right, so the question is like, when you get good, do you want to solve problems using structure? Because when I see people do the method 2, seriously, it's 1, 2, 3 steps, and then over here I had to multiply 9 times. I made a sign error, and then I had to combine like terms to get the answer. So because you have to, when you're multiplying a trinomial times another trinomial, you got to multiply 9 times because you have to distribute each term 3 times, and there's 3 terms to distribute. I mean, there's a lot of multiplications here, or products if you want to call them that. All right, so if you see structure, hey, that could be quick and easy once you get the hang of it, once you see it. All right, and that takes experience, my friends. It takes experience. All right, and not only that, doing things two different ways will back up your results. You'll check yourself. All right, so this is Mr. Ainsworth here. I'm just here trying to help you out. Do another prep right here before activity 3B3. So I'm going to put you guys in a breakout group right now, and you guys are going to go for it and try it on your own. All right, time to analyze. Here we go. I'll see you in my next activity.